Let's get started with section 6.1. So this is our last module. And in 6.1, we're going to talk about composition, inverses, and we're going to hit up logarithmics and exponentials. So that's really what we have left. So 6.1 is all about compositions. So you can see the four different compositions that you're going to be working with. You've got right over here, f of g. You've got f of f, g of f, and g of g. Basically, all compositions means is that we're going to take this second function that you see right here, which I really call the first function. We're going to take this function and we're going to plug it into f and get a new equation. Okay, same thing. All these second letters that you see here, they are going into the function. All right. So I usually call the second letter, that's usually the first function, and then this is the second function, okay? So it's kind of backwards to your thinking. And you also hear me call this fog, goff, thoth, and gog. So instead of saying f of g, it'd just be like fog, okay? Or g of f, I'd be like goff. All right? So basically all composition is, again, just like what I said, we're going to take this first function here, g, and we're going to plug it into f, okay? So f is what I consider the second function, g is what I consider the first function, all right? And the same thing with all the other ones. G is the first function and the second function in this one. Now down below here, I got how we talk about domains, because domains is a little different, because you have to consider both functions and their domains. So, and I've got an example of talking about domains I got three examples of this coming up. But the first example that we do will really express what's going on here, okay? So the first thing is any x not in the domain of the first function is out. So anything that is a bad value in this first function, like f there or g and f there, we are throwing out of the domain. And then right here it says for any x for which the first function is not in the domain of the second function is out. So I know this seems weird, but basically what it means is you look at the second function and you figure out what values are out on it. And then you set those values equal to the first function and solve. And that answer is the value that we're talking about right here that we have to throw out. Because if we take that answer and plug it into this value, it gives us one of the no-no values for the second function. Again, you'll see that here in just a second, okay? So let's do compositions. That's all 6.1 is about. So we come over here. So we're going to find the domain of f of g, fog. So the first thing is we got to worry about this function right here. What are the values that are bad in this one? And since it's a rational, remember all you do for the rationals is take that denominator, set it equal to 0, and solve. So x is equal to 1. So part of our domain, and they want your domains written in set notation. So part of the domain we're going to throw out in here is the number 1. Okay? Whoops. I've got my email on. Let's turn that off real quick. Go away. All right. So this is what I was talking about right here. Any x not in the domain of the first function is out. So here's my first function. There's the bad value. That guy is out. Okay? Now, we look at the second function. And what we need to do is we need to find the bad value for this. So again, it's rational. So we're going to set that denominator, which was x plus 2, equal to 0. And we find that in the second function, you have a bad value at -2. But we're not throwing out -2. What we need to do is we need to figure out when this guy, the first function, equals -2. Because if this equals -2, then that means we're taking this -2 and we're plugging it into our second function, which is a bad value. That's what this piece is saying right there. We're going to throw out any x value for the first function that is not in the domain of the second function. Okay? So what we're going to do is we're going to take this value, -2, and we're going to set it equal to the first function right here that was in red, 4 over x minus 1. Because we need to know what is the x value in here that produces a -2, which we have to throw out. Okay? So all you do, just like what we've talked about before, this is just cross multiplying because there's a 1 under that 2. So 2 times x minus 1 really looks like this. You are multiplying all of that. And then we got 1 times 4. So that gives us -2x plus 2 equal to 4. And we're then going to subtract 2. -2x equals 2. And then divide by -2, divide by -2. X is equal to -1. And this is the other number we have to throw out. Because when we take -1 and plug it into this guy, we get -2. And we know that that's a bad value for this. So our domain, we're throwing out the 1 from the first function. And we have to throw out x equal to -1 because that produces the bad value for the second function. And that right there is the domain. That's as hard as what it gets. Okay? Now, please know that the next two examples we do, these are going to be just like the examples that you see in the homework. You technically won't actually have to do anything like this, but I want you to know that's how you really figure out the domains, because in our next two examples, if you look at these guys, so here they are. This f of x has a domain of all reals. This f of x has a domain of all reals. So we're not throwing anybody out. That's why we don't have to worry about for these domains, because in the end, the domain will be all reals because we're not throwing anybody out. 2x plus 3 is a linear function. The domain is always all reals for linear. 3x is a linear function. The domain is always all reals. And the same thing for this second function, okay? The domain for f of x is all reals, okay? Because x squared plus 1 is a quadratic, and quadratics have domains of all reals. 2x squared plus 3, again, is a quadratic. The domain is all reals. Okay, so no matter what, all of these functions are going to have a domain of all reals because no one is being thrown out. Okay, so let's go ahead and I want to show you one of each one of these, and then I want you to pause the video and give the other ones a shot, because this is what you're going to have to do in the homework. Okay, so let's dive into this first guy right here. And I'm going to do f of f, okay? So what this means is we're going to take the function f, and we're going to plug it into f. Just so you also know, another way to write this, and actually all these I'll show you, f of f, or fof, looks like this. See how we're taking f and plugging it in to the f. Goff really looks like this. See how we're taking the G and we're plugging it into F. Fog looks like that. Goth looks like this. See how we're taking the F, plugging it into G. And Gog, it's a lot like Fof. We're just going to plug it into itself. Okay? So, since we're looking at Fof first, we're going to take this equation right there, and we're going to plug it back into itself. So anywhere in here where I see an x, I'm going to put 2x plus 3. Okay? So I'm going to start writing out my f function. 2. Oh, I see an x there. What am I going to put in it? 2x plus 3. because we're going to plug it right back into itself. So I'm going to put a parenthesis, 2x plus 3. Close it, and then I have plus 3. That's what it looks like when you do compositions. You're just taking the function and you're plugging it into another function. And this one, it just happens to be itself. And all they want you to do now is simplify it up. You know, do any distributing, combining like terms, that stuff. You're not solving, okay? You are writing a new equation. So if we distribute through, you get 4x plus 6 plus 3. And then when you combine like terms with the 6 and the 3, you get 4x plus 9. And that is FOF. Okay? Go ahead, pause the video, try the other 3. All right. So if we're doing fog, so I'm going to start with the F. Oh, I see X. What am I putting in for X? Well, it's going to be the G. So I'm going to put a 3X plus 3. Okay? Because in this one, this was our first function, and we're going to take and we're going to plug it in right there. That's what they wanted. So now you just do a little bit of cleanup, like I said. Do a little bit of multiplying. 2 times 3x is 6x plus 3. And there you have the answer for fog. It really is that easy, I promise you. Okay? So let's look at the next guy. Let's do Goff. So we're going to take f of x, and we're going to put it into g. So it's going into x right there. Okay? So that's going to give us 3 parentheses. Oh, it's x. So I'm going to put 2x plus 3. Okay? So all I got to do is a little bit of distributing. So 3 times 2x. That gives us 6x. And 3 times 3. That gives us 9. And there you have Goff. And then last but not least, we're going to do Gog, where we take the the G function and we plug it back into itself. Okay, just like what we did with FOF. We're going to take this guy and put it right back into X. So I've got 3. Oh, I see X, so I put 3X. Because we're plugging it into itself. And 3 times 3X is 9X. So for all of these, if you're looking at that domain, again, these are going to be all reals. And it will ask you about the domain. It's all reals because we're not excluding anything from the original functions. Okay? This function is all reals, which is g of x. Stop it. G of x is all reals. F of x is all reals. Nothing's excluded. So all these have a domain of all reals. There are no x's being excluded. All right, let's look at this one. I will do fog on this one. So in here it says we're going to take G and we're going to plug it into F. Okay? So, oh, I see X. So that means I need to put 2x squared plus 3 squared in. And then plus 1. Now, again, we've talked about this, but I want to keep reiterating this. Do not distribute the 2 through the parenthesis and say that this is 4x squared plus 3 squared. Or, yeah, because the 2 squared would be 4. So 4, actually, x to the 4th plus 9. Do not say that it is 4x to the 4th plus 9. That is not true. Okay? This power there means that you have 2 of these guys. And you need to write those 2 parentheses out. because what we need to do now is FOIL. First, outer, inner, last, and then we combine like terms. So what is 2x squared times 2x squared? 4x to the fourth. What is 2x squared times 3? Positive 6x squared. 3 times 2x squared, positive 6x squared. And 3 times 3 is a positive 9 plus 1. So in the end, when we combine all like terms, we get 4x to the fourth. The x squareds are going to get together and become a positive 12x squared. And the 9 and the 1 get together and become a plus 10. That is the function they want. Okay? Go ahead, pause the video, give these other ones a try. Okay. So, in here, now, looking at, let's go ahead and do FOF. That means we're going to take this piece right there and plug it right back into itself. Actually, let's change up the color. There we go. Finally got the eraser to work. So we're going to take x squared and we're going to plug it right back into itself. So, oh, I see an x. So that means I need to put x squared plus 1. And we're going to square that and then add 1. So again, just like what we talked about, there are 2 of these parentheses that you have to FOIL. Okay? Oops, I don't know why I put a squared again. I needed to put another parenthesis. Silly me. And then plus 1. So when we FOIL out, x squared times x squared, x to the fourth. X squared times 1 is x squared. 1 times x squared is x squared. 1 times 1 is a positive 1. And then we're going to add 1. So cleaning up, we get x to the fourth. X squared to get together become 2x squared. The 1's get together and become a plus 2. And there's our equation. It is this easy, I promise you. Okay, so now the last 2. So we're going to do GOF. So that means we're taking F. We're going to plug it into G. All right, so it starts out with 2. Oh, I see an x, so we're going to put x squared plus 1. And then we're going to add 3. Oh, and that is squared as well, too. Add 3 on the end. So now, this one's a little bit longer because we have the 2 to contend with after we FOIL our 2 parentheses. Okay? So this is what it really looks like. So let's do some foiling. Oops, I don't want to change my color. So x squared times x squared is x to the fourth. That 2 is still in front, and there's a parenthesis there because we got to FOIL that through or distribute it through when we're done. X squared times 1 is x squared. 1 times x squared is x squared. Oops, another positive x squared. 1 times 1 is 1. And then a plus 3 on the end. And then now, we need to distribute that 2 through. So that will give you 2x to the fourth plus 2x squared plus 2x squared plus 2 plus 3. And now the final cleanup, you get 2x to the fourth because no one gets together with that guy. The 2 x squared plus 2x squared, that gives you 4x squared. And the 2 and the 3 give you a plus 5. And there it is. Easy peasy lemon squeezy. And then last but not least, you'll do GOG, where all we're going to do, just like before, we're going to take G and we're going to plug it into itself. Okay? Haven't done red. So we're going to take this guy and put it right back in. All right? So let's do that. So we start out with a 2. Oh, I see x. So we're going to put 2x squared plus 3, and that is squared, plus 3 on the outside. See, we just plug G into itself. So again, this really looks like 2, and then it's 2x squared plus 3 times 2x squared plus 3, and then a plus 3 on the end. So doing some foiling. So again, we'll have that 2 with a parenthesis because we're going to distribute that after I'm done foiling. That gives us 4x to the 4th, because 2x squared times 2x squared is 4x squared, or 4x to the 4th. 2x squared times 3 is a 6x squared. 3 times 2x squared is again another 6x squared. 3 times 3 is a positive 9. Close that parenthesis and put the plus 3 on the outside. Okay. Now distribute everything through. So 2 times 4x to the 4th is 8x to the 4th. 2 times 6 is 12x squared. 2 times 6 is another 12x squared. 2 times 9 is 18 plus 3. And the final step, combine like terms. 8x to the 4th. The x squareds are going to get together, which give you a positive 24x squared. And finally, the 18 and the 3 will get together and give you a plus 21. And there is the answer. Again, just like before, no x's are excluded in these domains up there. This domain is all reals. This domain is all reals. There are no x's that are excluded. So therefore, all these domains are all reals. In other words, no x's are excluded. Okay? Last but not least, in this section, they will give you a function. This one is h of x that's already been combined together. And they want you to take it apart. They want to know what's f of g for this function. So what is the original f equation? What is the original g equation? So in other words, when I take g and plug it into f, I get this. Cool thing about this is that it is multiple choice. So you can actually just take each answer, take the g, plug it in, and see which one comes out to this. But I will let you know they're going to keep things pretty easy for you. You can kind of see that it's really kind of got two functions here. You've got this piece inside a parenthesis, and then there's that power on the outside. That's a lot like what you saw over here. See, look, this was one of our functions that we plugged in, and on the outside it was squared. Same thing right over here. So my advice to you is, if you've got some sort of function inside a parenthesis, that's really the first guy that got plugged in. Your g is 1 plus x squared. And if I take this piece out, what was originally there for f? X cubed. Because you can see that if I take this function right here and plug it in there, I get right back to that h that I had a second ago. So these are really the two original functions. And again, they're going to keep this very, very straightforward and simple. So if you see parentheses with a function inside of it, that's g. And then if you take that out, just replace it with an x, and that becomes the f part. Okay? It really is meant to be simple. Try not to overthink it, even though there are lots of ways that we could have separated these out. So just kind of show you, like, for instance, I could have had this be my two functions. I could have just had it where all I wanted to do is plug into that piece. So my g of x was x squared, and my f of x was 1 plus x cubed. See how I just took this piece and I'd plug it right in for that x, and I'd be right back to where I was. Again, they're not going to be that fancy or anything. They want it to be pretty straightforward, like what I just showed you a second ago. Okay? The other thing they could have done, and this would have been just lame, but these are two other ways they could have done this, and they're not going to do this, I promise. But let me show you. So another way that they could have done composition to this, and again, all these answers that I'm showing you are correct, but this is a multiple choice, so they only want the one answer that they want. Okay? This is what I call the cheap method. Why don't we just let this g of x be x, and then all I got to do is plug into the equation, which would look like this. Again, this is just the cheap way of doing this. So that would be my f of x. Again, because if I take x here and plug it into this guy, that would just be the same thing over again, because I'm not changing anything here. Or you could reverse these two. This is the other cheap way. What if f of x was just x and g was the entire function? So right there, these are three different ways that we could rearrange that function that we have up there. Again, this is the answer that they're really looking for. Okay? These are just other ways I wanted to show you that it could be broken apart. Okay? Again, use their answers to your advantage. All right? Use them against you. Use it against them. Because all you got to do is take the g function, plug it into the f, and see if it gets you right back to that h that we have. All right, I got one more. Go ahead and give this one a shot. Again, think pretty straightforward on this, all right? And pause it and write out what is your f of x and what is your g of x. What are the two functions that make this up? Go. Okay, so again, this is just like last time. This is fog, even though I probably should have put that there a second ago. This is always going to be fog. They want to know how am I plugging g into f so that I get this h of x. Okay, well, right there, just like last time, that's the g, 1 minus the x squared. Because this radical is acting like it's got a whole parenthesis down here. Okay. So then what does that make the f? Square root of x. That's the straightforward answer that they want you to do. Because if I take this piece right here and plug it in right there, I'm right back to the h. Okay? Again, they want it to be the straightforward answer. Now, I could again go through and show you those other three answers, just like what we did a second ago. And they are valid. Okay, they do represent a way to decompose these, but yeah, again, just like what I said a moment ago, just use their multiple choice against them. And that, my friends, is 6.1.